Pradeep, I am audible?
Yes, sir, you're audible.
Okay, okay. Voice is clear, no? Today?
Yes, sir, you're clear.
Okay, okay. Let's wait 5 minutes, then we'll start.
Yeah.
Hello, I'm audible.
Yes, sir.
Okay. Okay, let us start. I think. Okay, let us start. Welcome in week 7 fluid mechanics live clear. Now we'll move on the question number 1. Just wait. Basically, the week 7 is about the dimensional analysis. It is very important. As you can see the here the objectives. What is the objective of the dimensional analysis? The lecture 1 was about the dimensional homogeneity. We'll learn, we'll see the what is dimensional homogeneity with some example, basic example. And the lecture 2nd is about the dimensional analysis and similarity. As you see here the figure of one board is there. So how the model of board is prepared and tested. So these kind of things we can learn if we know the dimensional analysis concept, how it is work. The main objective is this dimensional analysis for the engineers and scientists is what understand the concept of dynamic similarity and how to apply the experimental modeling. Whatever you learn in the dimensional analysis, how you will apply in the physical world as well as you performing the experiment. The most benefit is that you prepare a model of your study and you can do the experiment with very minimum cost. We'll see all the example in the next coming slides. So first we see the first question, what types of questions asked. So these are the questions you know from the very basic. I think in the 11 class 11 this type of question you have also solved. So please do attempt for the answer. Actually answer is written here. The option number C is correct, but how it is correct, you just whether option C is correct or not, please do on your copy and write your answer in the comment box whether the option C is correct or not. Then I will explain how we will calculate the dimensions. So please write your answer in the chat box. Just you do some dimensional analysis kind of thing for the first question number first, whether the option number C is correct or not. And after 5 minutes, I will explain how can calculate. After this question, I have some concept. Kinematic viscosity and force, surface tension and the density. The list 2 is given the dimensions and based on the dimension you select the option whether the option number A, B, C, D which one is correct. Already someone give the answer C, but option C is correct or not, you just check. These are the previous year questions. This question I will tell you from the very basics and very fundamentals. Then after we will follow the standard fluid mechanics units. But for this question, I will go to from the very basic. So please write your answer in the chat box. Just please write your answer in the chat box. Anyone? Okay. Option C is correct. Pradeep is telling. Okay. We have to go with the units. Okay. Yes. Okay. Let me tell the how we can calculate if anyone not know. So basically the kinematic viscosity is what from the very basic of the fluid mechanics from the first lecture of the fluid mechanics the kinematic viscosity basically this is not mu is equal to dynamic viscosity divided by rho. This is the kinematic viscosity. You all know the one principle Newton's law of viscosity. Tau is equal to what? Tau is equal to mu du by dy. One thing I want to tell you, this relationship, Newton's law of viscosity is valid for the laminar flow, not the turbulent flow. So this is the very basic. So this is the shear stress. This term represents the shear stress. So shear stress is what? Force by area. Any stress is the force by area. Force by area is equal to, we have to find out the unit of this. Now, this is the velocity term and this one is the depth. So for force is equal to what? Mass into acceleration from the Newton's law of second law of Newton, and here the m is into a divided by area is equal to mu, and velocity is velocity and y. For m we need to write kg. For this acceleration is meter per second square and area that is the meter square is equal to, you know about the mu, velocity meter per second and y is the, okay, so this is cancel out and 1 second here, 1 second is cancel out, 1 meter here, 1 meter is cancel out. What is remaining? Kg divided by meter second, mu. For dimensional analysis, what you write? Kg will write in terms of kg represented by m, and meter is represented by L, and second, that is the time, is represented by T, mu. So you go with that concept. Mu is this, and what is rho? You know from the very basics, the density is what? Mass divided by volume. For mass, that is the kg, and meter cube. So this is m divided by l, m divided by l. So for mu, what do we do? M divided by lt. This is the for mu, and rho is what? M divided by L cube. When you will multiply, when you will the rearrange things, what will happen? The M and M things will be the cancel out, and L cube will go up. That is the L cube divided by LT. This is the, and one L is cancel out. So what is remaining? L square, and T is below. So you can write the L square and T minus 1. M is not there, so you can write here the M is M to the power 0. So final is M to the power 0, L square, T minus 1. This is the dimension of kinematic viscosity. Using this concept, we will calculate the dimensional analysis, and this thing will help a lot in the practical experiments, and basically in finding the dimensionless number. We'll see in the coming slides. So that is the m0 L square and T, that is the P option. Your kinematic viscosity is represent what? That is the this one. So similarly for force, you know the force is equal to mass into acceleration, whatever I have explained here. So this is the mlt minus 2, you know already. mlt minus 2, you can calculate m for the mass, and L minus 2 is what? L is acceleration is meter per second square, so that's why the m and t square, that is the for second. So option number C is correct for this question. The similarly you follow the all these things. So I think everyone got it about the concept behind this. I think it is very easy. Not Hardik, what about you? You understand? Yes, please write your answer in the chat box. Yes or no, whether you getting or not what I explaining. Hardik and one. Okay, okay, no problem. And Nivitya, you are getting. If you are getting, please write your answer. Yes or no, Nivitya. Okay, we'll move on the next. We'll move on to some basic concepts. So as you know from the very basics, your 11th class, the primary dimensions is this. There are 7 primary dimensions: mass, length, time, temperature, electric current, and the amount of light and the amount of matter. This is the representation of symbol, and these are the unit. SI unit, and this is the English unit. So basically we follow the SI unit generally in India. So the primary dimension you know already. So These things, these three things, mass, that is I want to write here, mass, length, and a time. These three things we will use in the fluid mechanics a lot. These are the primary dimensions. These are the primary dimensions. Basically, we for mainly in the fluid mechanics we will use. And for the mechanical point of view, temperature is also very important. In the mechanical, the temperature things is very important. But as for the civil concern, these three dimensions is very useful. Okay, the temperature is also. So dimensional homogeneity is nothing but there was the first lecture was about this. The dimensional homogeneity, as you can see here, uh, the two fruits are same thing and the third fruit is different. So you cannot add the apple and orange. So one statement is written here. So for adding anything, you need to the dimensions should be same. Let's say if you want to add something, 10 kilonewton force is given, one is the 20 kilonewton given, and third is given 30 kilonewton per meter square. So if we want to add, we cannot add the all three. Why? The dimension is not, that is the unit is not same for all three, for all three. So what we do, for adding this all three, we need to convert this kilonewton per meter square in newton, that is in kilonewton, then after we can add. So this is the meaning of the dimensional homogeneity. Homogeneity means everything should be the in the same, in same units. Like for just sake of understanding, Bernoulli equation, what is the Bernoulli equation? P by rho z plus v
Sir,
square by 2z.
why the M is small, sir? It should be generally it should be
Yes,
capital.
yes, please. You are not audible clear.
Sir, where the M is small, it should be I think capital.
Yes, you're not audible, Pradeep. Just wait. I think volume is.
Uh,
Yes, yes. Still again.
I think that this M should be capital, not small. Like T is small because it's time and T is capital T is temperature, but M should be I think capital M. So is there any other M also for symbol?
Oh, you are talking about symbol, right?
Yes, M should be capital again.
Yes, it is based on your. This is not okay. What you are following, basically, where I have taken the content from which book is written clearly. For the mass is taking the small m. You can take the capital M. Someone for the mass can take the another thing. No problem. It is the only representation kind of thing. So it's okay. Capital M you can also take. No problem. This is the basically representation. Somewhere the temperature is represented by theta, but here is the temperature is represented by capital T. So this is not big issue. As per our convention, we can take a capital or a small, no problem. But should be the concept should be clear. So now, for just for your understanding, I want to tell something about the Bernoulli equation. P by rho z v square by 2z, and here is the z is equal to constant. So P by rho z and the v square by 2z and z. Z is the what is the datum height? So it is in meter. This quantity having the same unit meter. This quantity having the same unit meter. If this one is not having meter, we cannot add. For adding things, we need to have the similar dimensions. That's why. So this is the meaning of dimension homogeneity. Let's for check Is it clear? Is it the having the meter unit or not? So V square means meter per second square divided by 2 into, that is a 2 is a constant, no meaning here, the meter per second square. So what is, that is the meter square divided by second square divided by meter second square. Second square is cancelled, and the 1 meter, this is 1 meter is cancelled, so meter. So unit is meter. So this is the meaning of homogeneity. You can add and subtract anything uh, uh, until you for adding or subtracting anything you need to maintain the dimensional homogeneity kind of thing. So basically these are the concepts. These are the examples. You no need to, if you want to take a screenshot you can take, just for your sake of understanding how it is calculating or not. This question is about the surface tension, that is the force by length, how we calculate the. Now moving, so here is a very beautiful definition. A dimension is a measure of physical quantities without numerical value, while unit is a way to assign a number to dimensions. For example, the length is a dimension but centimeter is a unit. So just for sake of your understanding I have taken this figure, so you can take a screenshot, no problem. The length is a dimension but centimeter is what, unit. And why we need the centimeter? Because some assigning the numerical value, that is the 2 centimeter, 3 centimeter, but you cannot tell the 2 length, 3 length. So this is the concept behind it, the length, dimension and the unit. So dimensional analysis and similarity, you can see here the model. This is the prototype kind of thing. This is the building, one building, two and three building, big building. But for the analysis of the of how much the velocity is acting on the, after the wind, let's say the wind is blowing, and how much the effect on building, if you go for the experiment like the such prototype kind of thing, it's a very costly. But do the dimensional analysis and make the model and then study, then it is very cheaper and uh, very cheaper. So basically this is the model. A small thing is model and the big thing is the prototype. So your existing thing, let's say your car, your bike, or whatever, your bike or car, this is the prototype kind of thing. When you do, before designing the your bike and car, what people do, make the smaller kind of thing using the dimensional analysis, and same type of forces like the wind force and other type of force apply on that, and just check what is happening on the model. Then based on that we implement the, we implement the correction kind of thing in the designing of the main thing, that is your car and whatever you want to design. So this is the basic dimensional uh, model and prototype. So this is, so the analysis behind it, how to convert the prototype parameters into the model parameters. So this is the dimensional, this analysis we know the dimensional analysis. You can take the screenshot of this slides also, no problem. Now for similarity should be the geometric similarity and the kinematic similarity, and also the dynamic similarity should be. Now, what is the kinematic, geometric, and or dynamic similarity? Let's understand. The second condition, geometric similarity, you know already, the length is length, width, whatever is the same. The kinematic similarity, which means that the velocity at any point in the model flow, that is the point here is talking about the point at any point in the model flow, must be proportional to by the some constant scale factor, that is the, let's say, or velocity in the prototype kind of thing. Prototype means the actual thing, is that is the 10 meter per second, and you are going to design some model velocity in the model. It should be the some constant factor, let's say the k times 2 meter per second. That is the, in your model you going to apply the velocity is 2 meter per second. Based on that, you prepare the dimension, you make the geometric similarity. Basically, these all things are the interlinked. We'll see when we discuss about the Freud model and the Reynolds model. We'll see the how the velocity and length, that is the kinematic similarity and the geometric similarity, how it is related with each other. Must be proportional to the velocity at the corresponding point in the prototype flow. Okay. Especially for the kinematic similarity, the velocity at corresponding point must scale in the magnitude and must point in the same relative direction. As you know, the velocity having the both direction as well as magnitude, so it should be maintained. You may think of the geometric similarity as length scale equivalence, and the kinematic similarity is the time scale equivalence. The geometric similarity is a prerequisite for the kinematic similarity. So this is the what I was telling. For the kinematic similarity, you have to first do the geometric similarity. Just a geometric similarity scale factor can be less than equal to, these are the things. Maybe greater than, if you want to design some small part, small things, your model and prototype, it's maybe bigger or smaller, it's depend on what you are going to design. The third most, the third and most restrictive similarity condition is that the dynamic similarity. The dynamic similarity is achieved when all forces in the model flow scale by the constant factor corresponding to the force. That is, the in dynamic similarity we maintain generally the force, that is the force scale equivalence. As with the geometric and the kinematic similarity, the scale factor of force can be less than or equal to it is telling same. Okay. So in general, what is written here? In general flow field, complete similarity between the model and prototype is achieved by only when three only when there is a geometric, kinematic, and the dynamic similarity. For complete similarity, if you want, you need to the all similarity. You have to do the all similarity, geometric, kinematic, and the dynamic. So as you know the Buckingham Pi theorem, so we'll discuss about the Buckingham Pi theorem also. Before that, I want to go some question. Okay. So as you have done the week 7, the question number 5, uh, please write your answer in the chat box of question number 5. The number of pi parameters need to uh, express the function f is function f, a, v, t, and dynamic viscosity mu l. So please write your answer in the chat box. How many pi parameters you need? As you done the week 7, so I think these are the things discussed. But after this question, I will discuss some concept about Buckingham pi theorem. Just for your sake of understanding, I have one question. The number of pi parameters need in this. So please solve the question and write your answer in the chat box. Okay, Pradeep, you are telling for question number 5, A option is correct. So here question is asking about the pi parameters needed for this. For a function is given. So I need one answer. Please, anyone write answer. Then I will go for Buckingham pi theorem concept. Basically, why we need the Buckingham pi theorem? Basically, uh, for derive the expression for the non-dimensional parameters. Why non-dimensional? Because non-dimensional parameter is similar for your model and prototype. Like length is not it is having the dimension. So for length for your model and for prototype is different, but somehow you find out and you derive some non-dimensional parameters. So it is non-dimensional parameters is the parameter is having no dimension. No dimension means whether the your small is bigger, whether the things is bigger, and whether the things is smaller, the non-dimensional parameter will be the same. Okay, I was mute, I think. Oh, so Pradeep, your answer is 5. Is, for question number 5, option number A is correct. Okay, let's see. And Pradeep, okay, now
It
you
is
are telling the option number D.
it is D, yeah, change to D.
Okay,
MLT, that uh, MLT is there, yeah, minus.
okay. We will go through the some concept before discussing the answer of this question. I will go through the some concept of Buckingham pi theorem. So Buckingham pi theorem we need for the basically find out the non-dimensional parameters involved in the flow domain. Why non-dimensional parameters? Non-dimensional parameter is very important because for model and for prototype it will be the same. Let's say the fruit number of your model and fruit number of your prototype will be the same. If the fruit number for any model is 1 or 1.5, let's say 1.5, then for model it will be the 1.5. So for derive the expression for non-dimensional parameter, we need the Buckingham Pi theorem kind of things. So this is the motivation behind it, why we need the Buckingham Pi theorem for, and why we study the Buckingham Pi theorem. So now I want to go through the some concepts behind it. It is a very lengthy, but please be there. Okay, these are the things done. So before going the Buckingham Pi theorem, let's discuss about the some variable dependent, independent kind of thing. I am audible now. Please, anyone tell. I am
Yes.
audible. Yes. Okay. So we let uppercase Greek letter pi denote the non-dimensional parameters. Non-dimensional parameter. We have already discussed one pi, namely the Froude number Fr. Basically, this is a nothing. The one pi means the dimensional parameters is there. So in general dimensional analysis problem, there there is one pi that we call the dependent. Pi should be the dependent. Now I want to write dependent. Dependent meaning is what here? Let's say the your z is equal to something. Function is the rho gh. That is the z is equal to rho gh. So this is what? This is the dependent, and this one is the independent kind of thing. If we consider the density is constant, g is constant, this is the independent. As you increase the h, the your depth will be, you independent parameters is what? You free to increase the value of independent. So dependent will automatically increase because it depend on the independent parameters. So dependent kind of thing. This is the, and giving it the notation pi 1. Okay, for sake of understanding, we for the dependent we write the pi 1. If anything is dependent, we write pi 1. In general, the parameters pi 1 each in general the function of several other pi's. Is a function of several other pi's means what? Is a function of pi a comma pi b dot 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 pi n. So this is the meaning here.
So why H is independent?
Yes, just wait, Francis. You are not audible. Just wait. Yes, what you are telling?
So why H is independent?
Yes, what you telling? Why x is?
H is independent vector.
No, no. Just for your sake of understanding, I was telling. Just wait. if something is given here, let's say the y is depend on 2x plus 2x square plus 3x. So as you will put the value of x is, let's say the x is equal to 1, y at the x is equal to 1, 2 into 1 square plus 3 1, how much? 5. At y x is equal to 2, you are changing the value of what? X. If you are changing the value of x, that is, this is the independent. And dependent is what? If you are changing the value of x, your y is affecting. You are changing the value of x, let's say the 2, then how much y? 2 into 4 plus 3 into 2, that is the 8 plus 6. 8 plus 6 means what? 14. So y is affecting. So that is the meaning of dependent and independent. Is nothing, just for sake of understanding I was taking the this kind of thing. Here nothing but. So I think Francis you got it. Just for the sake of
So,
understanding I was taking the example. So
okay, sir.
now we'll move on the concepts. So as I was written here, that is a similar thing is written. That is the your dependent. This one is the dependent. Dependent uh, parameters is the function of lots of independence parameters. Here k is the total number of pi's. Total number of pi's means independent. Total number of independent parameter. Consider an experiment in which a scale model is tested. Let's say I want to model an experiment aeroplane. Aeroplane is a big thing, but I want to modify the wing of aeroplane. So as I have prepared one model kind of thing, that is the biggest big aeroplane, I have reduced with the dimensional analysis in the small kind of thing. The meaning of here, the experiment in which the scale model is this, the big thing we reduce in the small things, is tested to simulate a prototype flow. Simulate meaning is this. Simulate meaning is here the analysis, the blowing the air, and what is the what happening with the wings, and what happening with the your aeroplane. That is the simulation. And simulation, now we are using the simulation term in the CFD. That is a computational fluid dynamic kind of thing. That is the, you write the equations, that is the your Navier-Stokes equation, or as you know the Bernoulli's equation, all these things we write the programming for using utilizing this equation and generate the mesh and run the code. So this is the things, the running the code for see the where is the pressure is, where is the velocity is more, pressure is more. This is also known as the simulation kind of thing. I think you all know about it. Just for someone not know, that's why I am explaining more. To ensure the complete similarity between the model and prototype, for complete similarity, we have seen the previous, the for complete similarity we need the all kind of thing, that is the geometric, kinematic and your dynamic. What is written here? To ensure the complete similarity between model and the prototype, each independent, that is the these things, each independent pi of the model subscript m means model, must be identical to the corresponding independent pi of the prototype. This is the nothing but your prototype independent parameters must be equal to your model pi. This is the meaning here. Using the sum factor, what I was explaining the previous. So now, to ensure the complete similarity, the model and prototype must be geometrically similar. and all independent pi groups must match between the model and prototype. It's not like that. Your model is depending only on length, that is the length and width and dynamic viscosity and let's say the density in model, but in the prototype length, width and dynamic viscosity only the independent variable. This should not be happen. If here is 4, then in model, if in your model is 4 independent, then in your prototype should be the 4. Then it is what is written, the meaning of this is that under these conditions the dependent pi of the model is guaranteed to also equal to the dependent of prototype. This is the meaning. If the independent thing is equal, then dependent thing will be equal, and the mathematically is written here. This is the nothing but the mathematically is written here. The pi 2 of model, the pi 2 of prototype will be the equal. Now we'll take one example is written here, the prototype car and the model car. This is the bigger one. This is the prototype, and for a study we one consider the model car and analyze based on the result on this, modify the geometry of the car. As you remember the shape of jeep in the previous one like this, that is a vertical kind of thing, but now the car is like this shape. So after doing the lots of experiment, people understand and modify the things. So now we consider and if considered, for example, the design of a new sport car. This is the basic for the your Buckingham pi theorem. We are why we are studying this pi and all dependent or independent, just for the Buckingham pi theorem. How this, if you understand these things, dependent or independent kind of thing, then very easy you will understand the Buckingham pi theorem. And one example I have also, then I will explain the question thing, how many pi required. Okay, for example, the design of a new sport car, the aerodynamics of which is the aerodynamic means what the air is flowing on the car and what is happening with the air, like pressure, where is the much pressure, where is the drag force, lift force, this kind of thing. And the dynamic due to air, this is the air dynamic. So the aerodynamic of which is to be tested in the wind tunnel. You know the wind tunnel is, I think you have seen the wind tunnel. If you not seen the, you just Google and see what is wind tunnel. In the wind tunnel, basically we blow the wind on the model car or on the prototype car and see the how the formation of boundary layer, where is the more pressure, where is the drag, how much drag force acting, lift force, this kind of thing analyze. To save money, it is desirable to test a small, that is geometrically scale model for the car rather than the full scale prototype of the car. What I was telling, this is the written here simply. In the case of aerodynamic drag on an automobile, it turned out that if the flow is approximated as incompressible, there are only two pi's in the problem. Which pi? One is the dependent and another one is the independent. The dependent thinks is what? That is your pi 1, that is the drag force. And independent thinks is what? Your Reynolds number. Now, how much your velocity, your length. If basically your Reynolds number is more, then drag force will be affected. So these kind of thing. Your drag force is coming due to the what? Your velocity, how much velocity, density of fluid, dynamic viscosity of fluid. Based on that, only the drag force is will be the more or less. It's depend on these kind of things. So that's why this is the dependent and this one is the independent. So here two is things. The procedure used to generate these pies is discuss how we can generate these things. It is a Buckingham pi theorem. We'll see in the below sections how. In the equation 713, Fd is the magnitude of the aerodynamic drag, that is the how much drag is acting on that of the car, and the rho is the air density, v is the car speed. Okay, this kind of thing is written. L is the length of the car and mu is the viscosity of air. Pi 1 is a non-standard form of the drag coefficient and pi 2 is a Reynolds number Re. You will find that many problem in the fluid mechanics involve the Reynolds number. This is a general kind of thing. So no meaning here. The Reynolds number is the most well known and useful dimensionless parameter in all the fluid mechanics. This is a general term is written here. In the problem at hand, there is only one independent pi, that is this one independent, and equation above one ensure that if the independent pi's match, that is the Reynolds number match, your the Reynolds number for model, that is the Reynolds number for prototype, and the Reynolds number for model will be the equal. Then the dependent pi also match, that is the your drag force of the prototype and the drag force of your model will be the same, if these things will be the same. This when we do the some example, then you can understand more. Just for this sake of understanding, you just try to understand. If the independent thing is equal, then dependent definitely will be the equal. This enables the engineers to measure the aerodynamic drag on the model car and then use this value to predict the aerodynamic drag on the prototype car. So this is the basic fundamentals why we need the dimensional analysis. So you can easily see here the investing the very least cost, you can easily find out at how much velocity, if you're something in, if the velocity, let's say the wind velocity is very high, that is a 500 meter per second, what will happen with this car? So you can make the prototype and uh, do the dimensional analysis and blow wind and blow the wind in the wind tunnel, and you can easily get what how much the force will be at. So the Buckingham pi theorem, we can the method of repeating variable and the Buckingham pi theorem. So Buckingham pi theorem is nothing, is a repeating variable kind of thing. Which type of variable we repeat? Let's see. And with this concept, you will definitely solve the question number 5. What is the repeating variable? Only the repeating variable find out itself a big deal. But for sake of understanding, let's. I have one table also regarding that. So is it audible or
So we'll have a break for 2 minutes.
yes, please audible?
Yes, audible, sir.
Okay,
So
okay. Now
we'll have,
I will continue or go through the questions, please.
we'll have a break, sir, for 2 minutes, water break or something.
Yes. Pradeep, what you telling?
Sir, some kind of water break. So 2 minutes water break.
Oh, you want to break some 5 minutes?
If you like, sir, if you like to, yeah.
Okay, okay. We can take a break and then after we'll start after 5 minutes. Buckingham pi theorem. Okay, no problem. Let's break up the 5 minutes. Okay, we can start. Okay, no problem. Just wait 1 or 2 minutes. I think someone is. Just we can wait 1 minute, then we'll start. In between, you can read the what is written here. You can read. So now we'll start. So the method of after this question, after this slide, we will move on the question. The method of repeating variable and the Buckingham Pi theorem. What is? We have seen the several example, uh, but we have not seen just written here. So now we are ready to learn how to generate the non-dimensional parameters. Why we need the non-dimensional parameters? You know already. I have tell non-dimensional parameters for model and prototype is equal. So it is very easy to equate the both things. So there are several methods that have been developed for this purpose for non-dimensional for calculating the non-dimensional parameters. Several methods, but the most popular and simplest, popular as well as simplest method is the method of repeating variables. And this method of repeating variable is popular by the eager Buckingham. So that's why we know the Buckingham Pi theorem. But it is nothing but the repeating variable kind of things. The method was first published in the Russian scientist, whatever the name is there. We can think of this method as a step-by-step procedure or recipes for the obtaining the non-dimensional parameters. These are the steps given here. How we can calculate, and there are 6 steps in figure given, and the more detail in the table I have, I think table 7.2. Yes, more detail in the given, and you can take the screenshot also this, and then I will show the table. You can also take these steps are explained in future detail as we work through the number of problems. We can see in the problem this. As with most new procedure, the best way to learn by the example and practice. As a simple first example, consider a ball falling in vacuum. Ball is falling in the vacuum. Something is a ball is falling in the vacuum. Vacuum means no air. As discussed in the section 7.2 in the previous we were discussed. Let us pretend that we do not know that the equation 7.4 is appropriate for this problem, nor do we know the much physics concerning falling object. In fact, suppose that all we know is that the instantaneous elevation elevation of the ball we know must be a function of, and the elevation of the ball is was the function of time, initial vertical speed, and the initial elevation z naught, and the gravitational constant g, and this is the figure.
So can you zoom in the slide?
Yes.
Can you make the full screen slide?
Oh, it is not visible. Okay, 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 no problem. So Now is it visible? Now visible?
Sir, it's actually the same. I think we can make it full screen.
No, no. I have made the full screen. Is this visible or not?
It's actually the same screen I am having.
Okay. I don't know.
Sir, I will rejoin. Maybe due to network.
Okay. No, no. Pradeep, your question is about what is the difference between the pi and the Buckingham pi theorem.
The
Pi,
essential
your pi is a mathematics pi you are talking.
pi theorem, sir, pi theorem earlier that you what you discussed. Um,
Or
is
you are talking about the pi theorem.
Yeah,
No,
pi
no, this
theorem
is
is
the same kind of thing.
same theorem, right?
For dimensional analysis, pi, why we are using pi? We can use some another thing also, no problem. Just for representing the variables, that is the independent or dependent variable, we are using the pi. So you can use another thing, no problem. But concept should be the same.
So the pi theorem is same as that of Buckingham theorem.
Yes, yes, same,
Okay,
same.
okay, yeah.
Same thing is there.
Thank you, sir. Yeah.
So now we can, it's, Pradeep, you visible or not? Clear.
So I will just screenshot, sir. Then I'm just enlarging it in my text
It is
box.
visible right now.
Well, to be bit less visible, sir, but I can read it. Yeah.
Oh, here the question is given. Is it visible or not? This question, whatever I am.
So there is no question on the. Yes.
No, no, circle kind of thing. I am drawing. You visible or not?
No, 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 sir. Not visible.
Oh, not visible.
Yeah.
Okay.
We're not. I think your cursor not able to see.
Now I am writing something visible.
Yes, sir. Now it is visible.
Oh, but in full screen mode, I think not visible.
Yeah,
So
not
this is the
visible.
question. One
Yeah.
ball is falling, right? One ball is falling, and this is the initial elevation. So the question is this. In the next slide. Okay, I think. Okay, no problem. Francis is telling this is not visible clearly. So what I will do, just for your, because if it is not visible, there is no meaning of, because this is a very important. Now it is clear visible.
Yes, sir.
Okay. Because these are the step is very important for the Buckingham Pi theorem.
So Francis is left or he's not available.
Now I think clear visible, no?
Yes, sir. Yep. You can
Okay,
ask Francis. Francis can answer for it.
okay.
Yes, sir, it's visible.
Now is it visible, Francis? Hello?
Yes, sir, it is visible.
Okay, okay. Okay, now I will move through the concepts. So one ball is falling in the vacuum, as previous figure is says you can see. This is the ball is falling in the vacuum, and this the elevation of the ball must be a function of what? That is the time, your initial, what is the speed, your initial speed, and your initial height, and the gravitational. So number of, that is the, here is the five parameters. It may be the dependent or it may be the independent. That is the dimensional variable, non-dimensional variable, and the dimensional constant. That is the dependent or independent, nothing but you just understand your dependent or independent kind of thing. How much, that is the, this is 1, 2, 3, 4, 5. The, and they are listed in the functional form. That is the z is your function of these all these things, with the dependent variable listed as the function of independent variable and constant. That is the some variable and some constant also there. We include all these things, constant also, because you know the g is the constant. G is not constant, but we consider this is not much effect for this kind of. The step 2 is what? The primary dimension, as we have seen the earlier, the how much the primary dimension, the 7. I was telling the length, mass, length, and time is very very important for fluid mechanics, and also the temperature. That is the, for time we are using the small t, for temperature we will use the capital T. So primary dimension is this. The primary dimension of each parameter are listed here. We recommend uh, writing each dimension with the exponent, since these help in the later algebra. We will add something, we'll see the. So what was the z, was the function of z naught, t, w naught, z naught, and g. 1, 2, 3, 4, and 1 is 5. So z is the meter, t is the time, velocity is the L1 by t, that is the meter per second, so you just t inverse, and the L1 and the T1, this one. So how much the primary variable is here? So step 3 is what? As the first guess, j is set equal to 2. Why 2? The number of primary dimensions represent in the problem L and T. How many primary dimension is here? L and T. M is not there. So we are taking the j is equal to 2. After the dimension analysis, after the dimension written the dimension of the all parameters, we decide what is the value of j, and based on that, if the j value is correct, the number of pi predicted by the Buckingham pi is how much? That is the pi. K is represent the number of pi, how much pi required. That is the n, your total parameters, how many? 5. It may be the dependent, independent, or constant. And j is what? How many primary parameters, primary dimension involved in all the parameters, that is the 2. So that's why here answer is 3. Your 3 pi is required, that is your 5 function of the pi 1, pi 2, and pi 3. Not I think pi 3 is not there. We'll see pi 1, pi 2, and pi 3 is required or not. Yes, pi 3 will require. So So this type we can calculate the how many pi is required. Now we'll move on the question. What was the 5 number question? You can expect this question in the gate also. So your function is what? Your function f is area, velocity, time, dynamic viscosity, and L is equal to 0. How many? 1, 2, 3, 4, 5. N is equal to how much? 5. Now for J, you need to the dimension, write the dimension of each. A, for A is what? L square. V, for V is what? L1 T minus, that is a small t minus 1. For T, your a small t power 1. And viscosity, how much? For viscosity, you need to write, that is I think for viscosity or M, actually Newton second per, just I forgot. Let's write the, that is the force by area mu, and velocity by, when you forget you try to do, and velocity, and divided by y. So m l t minus 2, and m square, l square, and mu, and your, that is the meter per second, small t, and meter. Your meter is cancelled. mlt minus 2. So when you will multiply, what will happen? M1L is cancelled. So here 1L is remaining, and minus 2 into T. So your, that is the MT minus 1 and L minus 1. So this is the M M1 L minus 1 T minus 1. I think this is correct. If not correct, no. Here just we will see how much you required, and one thing is L. Your L is represented by, that is some length is given. So this is L power 1. So how many primary primary para required? That is what was written. How many primary dimension is here? One L is there. Okay, T is also here, and mass is also here. That is the M. So here 3 is 3. So how much? Your N value is how much? 5, and J value is how much? 3. How we calculate the J value? You know already. So number of pi theorem is how much? Number of pi is equal to your total number of parameters, that is 5, divided by the primary dimensions. How many primary dimensions involved here? That is a 3. So your answer is 2. So option number D is correct. Yes, Pradeep, your answer was correct. So with this concept, we, for the small concepts, we, for the small type of question, we need the strong concept. Then you can easily tell the answer. So I think everyone understand. Oh,
So actually the it's a 3, isn't it? So the pi value will be 2. One will be termed as dependent. Is that right?
yes. What you telling, Francis?
So we got the variables as L, T, and M. So 3 variables.
Yes, yes.
So the pi should be 3 or 2.
No, no. Your pi will be 2. Okay. Your pi will be 2. No, you are not getting, I think. Okay, the number of pi, that is the, what was the formula? K. K is represent the how many pi is required. That is the pi 1, pi 2, pi 3, pi 4, like that, dot dot pi n. How many pi required? For this question, number of variable is how much? Number of, that is your parameters 5, and the number of primary dimension is 3 involved in the, when we do the dimension of all the parameters, we see the 3 things is involved. So how many 2. Your for this question only two pi is required, pi 1 and pi 2. That is the pi 1 is the function of something pi 2. Right, you are getting. We
Yes,
have
sir.
seen in the previous one also. For this example, let me go up. You will be feel some confidence regarding that. Let me show. Yes, this question you have seen. In this question, we have only 2 pi, right? But how many variables is here? You just rho is there 1, velocity is 2, length is 3, mu is 4, fd is 5, 5 variables. But we have only 2 pi. That is the pi 1 is the function of pi 2. That is your pi 1 will be the dependent variable and pi 2 will be the independent variable. So let us move ahead. Let us for question number okay. We need in this question we need here 3 pi. What we are discussing this problem, the textbook problem, we need the 3 pi for this. And how we calculate the pi? You have seen here already, and one question we have already solved. In the previous question we knew 2, but here is the 3.
Yes, sir. Understood. Actually, I got the wrong, took the wrong formula. I mean, I took the k as the 3. That's
Which formula you got the wrong formula?
now I got the right formula. Actually, when I calculated, I
Okay, 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 no problem. Okay, so we'll move ahead the step 4, 5, 6, or we go for the question answer. Yeah, someone is asking about the recording. Yes, it is recorded. We'll upload after this session. I will upload maybe after half an hour. All will be. Pradeep, we'll go on for question more step or
As you like, sir. uh,
okay.
yeah.
Oh, I am thinking the step is more important than the question
Yes,
because
tape is more
question is
important.
already you have
Yep.
seen,
Yes, sir.
but a step concept is very very important for any kind of thing. Now we move on the step 4. Only step 6, 6 step is there in the question. So step 4 is what is written. We need to choose two repeating parameters. That is the we have seen already the Buckingham pi theorem is what the repeating parameters, repeating variable kind of things. So for the y repeating, just you have seen the we are going to select the two parameter which is repeated. So that is the repeating variable theorem also we know. Since y2 because of the j was 2. Since this is often the hardest because which parameter we select this is the very very difficult or at least the most mysterious. For this one table is given. I think I have table or not. I think table I have not, but for this example we'll follow the steps. How we select the two repeating parameters. For this some table is given. For this table you can guess easily, but not the hard and fast rule in the table is given कि you have to choose only this kind of thing. This is not only for the your enhance the concept for selecting the parameters is given in the table. So since this is often the hardest part of the method of repeating variable, that is the several guidelines about choosing the repeating parameter are listed in the table 7.3. We have not here. The following the guidelines in the table 3 or the next page on the next page was given, but I have not taken it. and the choice of the two parameters is what? That is the your initial velocity and the z naught. That is the initial height. We have selecting the two parameters, initial velocity and initial your height. Because why? Because these two parameters, these two repeating variable will not change anywhere, not going to change, because initial was fixed and your z was also fixed. So repeating parameter for this question we have selected initial velocity and initial height of the ball. Now we move on the 5.
So are we taking that randomly?
No, no, you cannot select the randomly because of the sometimes you choose the dependent variable, the repeating variable, some dependent kind of thing. So it is not randomly. Some guidelines for guideline. I think I have just yes. Table number 7. Is it visible or not? If someone want to take the screenshot, please take, because this thing will help you.
Okay,
Let
sir.
us yeah, let us read how will pick up the. Is it visible
Not so much if you divide this into two parts,
or
sir.
not visible? Right.
Not very clear. So
Okay, okay. Let us. Okay, if not visible, then what I do? I will divide these things into two parts. Oh, just copy. One line is written here. What I was telling. Now I think it is visible.
yes, sir, much better. Yeah.
Now visible.
Yes, sir,
So
completely.
guidelines is what? Let us read because it is very important. Anyway, you will get the concept, but guidelines is also important. Guidelines for choosing the repeating parameters. Step 4. What was there? So first, never pick the dependent variable. Never pick the dependent variable. Otherwise, it may appear in all the pies, which is undesirable. Because if you pick up the dependent variable as a repeating variable, no meaning. You cannot use basically no meaning of it is undesirable. Uh, Basic purpose is what of the dimensional analysis. We can this if you choose the dependent variable not fulfill. So guidelines is there. You cannot choose the dependent variable for the your as a repeating parameters. Now comments is what? Comments and the application to the present problem. What we are discussing the problem, the application is this. In the present problem, we cannot choose z. Why not? Z is what? Z is the function of, that is a final height, is a function of your initial z, your initial velocity, your time, and what was another? Let's say something was there, and g. Yes, g was there. So, but we must. So in the present problem, we cannot choose j, but we must choose from among the remaining four parameters. Therefore, we must choose two of the following parameters: t, w naught, z naught, and g. And why we are choosing only these two things? Let us move ahead. To choose the repeating parameters must not by the themselves. Okay, what was the Francis was telling? To choose the repeating parameters must not by themselves be able to form a dimensionless group. Yes. Otherwise, it would be impossible to generate the rest pies. Yeah, it is very very important. The meaning is it this what we can understand. In the present problem, any two of the dependent parameters would be valid. Any two of the independent parameters would be valid according to these guidelines what for illustrative purpose. However, suppose we have to pick up 3 instead of 2 repeating parameters. We could not, for example, choose t, w naught and the z naught because these may form a pi all of the themselves, because as you know the t, omega naught and the z, that is the time and meter per second, that is the this one is also time, this one is length and this one is length. So this is making a non-dimensional kind of thing. So this kind of thing you cannot choose. So the meaning is this. So this is written here. The chosen the repeating parameters must not be themselves be able to form a dimensionless group. So we have already dimensionless group. Otherwise, it would be the impossible to generate the rest of the pies. And what is next? The repeating parameters must represent all the primary dimensions in the problem. Okay, this is also important. The repeating parameters must represent the all primary dimension in the problem. Primary dimension you know already, 7 is there: mass, length, temperature, matter, you know already. I was discussing the first slide. So it should be represented. Suppose for the example, there were 3 primary dimensions: mass, length and time, and 2 repeating parameters were we chosen, and 2 repeating parameters were to be chosen. You could not choose say a length and time, since the primary dimension mass would not be represented in the dimension of repeating parameters. An appropriate choice would be the density and time, which together represent all 3 primary dimensions in the problem. Okay, what is written? Choose the repeating parameters must represent the all primary dimension. Let's say in the application part is what written. For example, there are there were 3 primary dimensions: mass, length and time, and 2 repeating parameters were to chosen. Let's say for another example, for this example not, for another example, the primary dimension is mass, length and time is there, and you want to choose the 2 parameters only, not 3. You want to choose the 2 parameters, 1 and 2. You want to choose the 2 parameters between them. So what you will do? You could not choose say a length and time. You cannot choose the length and time, because you have to choose these 3 things, because all 3 is involved in the problem itself. Since the primary dimension mass would not be represented in the dimension of the repeating parameters, so time and length, in the time and length mass is not representing. So what you do? An appropriate choice would be the density and time. In the density is equal to what? Your mass and length parameter is also there. So mass, length and time, everything is included in the density and time. So because you restricted to choose the only two, that's why you go the on the other parameters, which together represent the all 3 primary dimensions. So when you go to the choose, you already you think in the given problem whether the mass, length and time, if all 3 is there, then you choose based on that. If 3 is, if in your problem if 3 required primary dimension, if uh, three repeating parameter were required, you can choose the mass, length and time. If two required, then what you do, you go the another option, let's say density or another. So what is 4? Never pick the parameters that are already dimensionless. Dimensionless parameter you never pick up. These are pi's already. Okay. Suppose an angle theta where one of the independent parameters we could not choose theta as a repeating parameter since angle have no dimension. Radian and degree are the dimensionless unit. In such case, one of pi is already known, namely theta. The dimensionless, why? Basically, pi is what? Dimensionless. So theta is, if in your problem, that is the one pi is already. So you never choose the theta. That is your dimensionless parameters. What is the 5? Never pick up two parameters with same dimension or with dimension that differ by only an exponent. What is the meaning? In the present problem, two of the parameters two of the parameters what? Z and Z naught. What is written? Never pick up the two parameters with same dimension. With same dimension you never pick up. In the present problem, what the Z and Z naught have the same dimension of length. We cannot choose both of these parameters. We cannot choose. Note that note that dependent variable z, that is a dependent variable z, has already been eliminated by guidelines 1. The dependent variable you cannot choose, only the you have the option independent variable. So independent variable, so dependent variable, that is the z naught, you have not for z you not have the option. So suppose one parameter has the dimension of length and another parameter has the dimension of volume. In the dimensional analysis, volume contains only one primary dimension, that is the length, and is not dimensionally distinct from the length. We cannot choose both of these parameters. Okay, if volume and length is there, something, the volume and your, let's say, the width is there, so only you have to go for volume, other, and you can go through the width, not you can choose the both kind of thing, because both things involve only length. So I think you understand why z not we can, why z we cannot take, why we are choosing the z in the previous, uh, here, why we are taking z. I think you understand now. Only this thing is remaining. Let us move. Okay, so what is 6 is there? Whenever possible, choose the dimensionless constant over, whenever possible, choose dimensional constant over the dimensional variable so that only one pi contain the dimensional variables. What is written? If we choose time as a repeating parameters in the present problem, it would appear in all three pi's. Okay, while this would not be wrong, this is not wrong, it would not be this, since we know that the ultimately we want to some dimensional non-dimensional height as a function of some non-dimensional time and other non-dimensional parameters from the original four independent parameter. So this restricts us to the W naught and Z naught and G. So time we can take, but what is happening with time? What this is written in the guideline 6. If we choose the time as a repeating variable in the present problem, what will happen? It would be appear in the all three pi's, because repeating variable means when we write the pi, pi 1, then t term will be appear. When we write the pi 2, t term will be appear. When we write the pi 3, t term will be appear. While this would not be wrong, it would not be this, uh, since we know that the ultimately we want to some non-dimensional height. We want to some non-dimensional height, because why we are using the Buckingham? For the non-dimensional kind of thing. Non-dimensional things, that is a non-dimensional, that is the length by length is equal to the function of something non-dimensional. So we ultimately we want to some non-dimensional height as a function of some non-dimensional time and other non-dimensional parameters from the original four independent parameters. This restrict us to W naught, Z naught and G. What is 7 is there? Pick up common parameters since they may appear in each pies. What is meaning? In the fluid flow problem, we generally pick up length, velocity and mass or density. It is unwise to pick up less common parameter like viscosity, surface tension, since we would in general not want mu and surface tension to appear in each of the pies. In the present problem, W naught and Z naught are the wisher choice than G. So why G is, let's again read the this option 7, guideline 7. In the fluid flow problem, we generally pick up length, velocity and mass or density. These three things we generally pick up. Length and velocity and mass, or you can say the density. It is unwise to pick up the less common parameters. Why we are choosing? Because if you see the formulas, length, velocity and the density is always there. Density is always there in the most of the formulas. But your now what is in the unlike to pick up the less common parameters like viscosity or surface tension, since we would general not want to the mu and G as that is the your surface tension to appear in each of the pies. In the present problem, W naught and G naught are wiser to choice than G. And one thing is also important, I will tell just after reading this. 8. Pick up simple parameter over the complex parameter whenever the possible. Simple parameters you always choose. It is better to pick up the parameter with only one or two basic dimensions. Example, a length, time, mass, velocity. Instead of the parameter of composed of the several basic dimensions, that is the energy and pressure. So this type of you already you avoid kind of thing. Only less dimension, very basic dimension, one or two basic dimension parameters having that you select. One thing is important is that in the several studies, in the several practical problem, what we assume mu is the constant, surface tension of water is constant everywhere, and the your G is constant. So we we are going to choose already this is the constant. Already this is a constant, that is the value wise constant, not the dimensional wise constant. So the option number, that is the guidelines number 7 is written telling about that pick up the common parameters since they may appear in the each pies. That is the in the fluid flow problem we generally pick up length, velocity and mass. You remember, always remember. And it is unwise to pick up the less common parameter. That is the when common, because these are the guidelines. One line is written here very these guidelines, while not infallible, help you to pick up the repeating parameter that usually lead to establish non-dimensional pi group with a minimal effort. This is not a hard and fast rule, but after the solving the lots of problem, these are the guidelines is only given here. So we'll move on the question number 5. Why we choosing the here? We have the option Z naught is Fox function is the Z naught, W naught, time and G. So we are choosing only this is not dependent variable we cannot use. Time this is not wish to choose, and the G is already C. Already you have seen why we are choosing here W naught and the Z naught as a repeating variable. So now the 5 after that I think you all know, no problem. Now we combine these repeating variable, repeating parameter into the product with each of the remaining parameters on a time to create pies on at a time. Let's read again. Now we combine these repeating parameters. Okay, parameters repeating is what? W naught and Z naught into product with each of the repeating parameters. Remaining parameters is what? That is the remaining parameters your G and time. This is the remaining parameters and Z also. Remaining parameters to create pies. Create pies means what? Non-dimensional kind of things. Let's say length by length or maybe the time by time. So this kind of thing, non-dimensional. The first pi is always the dependent pi and is formed with the dependent variable. So these three you have remains parameters. So first one is the with the dependent, that is the Z. Z is written here and W naught and Z naught. This is the repeating. So what you will do? You just raise the power a1 b1. You know already. We have also I think in the 11th class you have already know about that, where a1 b1 are the constant exponent that need to be determined. Okay, we will determine, and we apply the primary dimension of a step 2 into the equation this for the force, and then pi 2 then pi to be dimensionless by the setting the exponent of each primary dimension to 0. So we will nothing do for dimension pi. What we do, for the dimension pi only here L and T is involved, that is the length and T is involved, that's why here T is T to the power. For the pi we have written the dimension L0 and T0 and the power is written here Z, that is the length, and W velocity L1 and T minus 1 power A. So you already know that T0 and T minus 1, that is a T1. So these are the equal. So minus a, that is the minus a equal to 0 and a1 is equal to 0. Now length, you go for the length. The length is L0 here and L1 and the a1 and b1. So 1 a1 b1. Your a is the a1 is the 0, so your b is equal to simple the algebraic function is minus 1. So if you put here, if you will put pi is equal to b is minus 1 z and w naught to the power 0 and z naught to the power minus 1. So what will z and w to the power 0, it is 1, and z naught to the power minus 1, that is the your z naught. So length by length. So your this is a dimensionless. This is a dimensionless. Similarly, where it is okay. Similarly, I think it is visible. Similarly for pi 2, for pi 2 and similarly for pi 3, you will do what you will get. For pi 2 you will be get these parameters. For pi 3 you will be get these things. After that, what you will do, all three pi's have been found, but at this point it is prudent to examine them to see if any manipulation is required. We see immediately that pi 1 and pi 2 are the same as the non-dimensionalized variable z star and t star. Z star t star means nothing but z by z naught is equal to z star and t star similarly. Find out by the equation this. No manipulation is necessary for this. However, we recognize that the third pi must be raised to the power 1 by 2 minus 1 by 2 to be the same form as established the non-dimensional parameter, namely the fruit number is this. So if you power you will the raise, then this thing will be the non-dimensional things will be appear. So let us check pi 2. Your pi 2 is what? W naught divided by Z naught into T. That is a meter by meter per second into second divided by meter. This is a non-dimensional. For this, for pi 3, that is the G Z naught W naught square. What will meter per second square into meter and the meter square, that is a second square. So this is also non-dimensional. This thing, because meter square second square. But why we modified these things? Because we know already the one established fruit number, one established non-dimensional. For converting the fruit number, we just use this raised to the power minus 1. Uh, you can put as it is, no problem. But for the we know the already uh, one established dimensionless parameters, so that's why. So hint of the day, what is written? A wish choice of the repeating parameters for the most fluid flow problem, length, velocity and mass, as well as you can take the density, no problem. So this is the whole concept behind it, the choosing the pi and all. Guidelines for manipulating the pi's, you can take the screenshot, no problem. So for last step is what? We should double check the pi's are indented the dimensionless. Let we check already, we check the all the dimensionless. You can verify this on your own. And the present example, we are finally ready to write the function relationship between the non-dimensional parameters and combining the all equation. That is the your dependent pi 1 is what? For the dependent is the function of all independent pi's, that is a pi 2 and pi 3. So what was your independent? Pi 1 you are getting this is the function of what? W naught T Z naught comma W naught divided by Z Z naught. So this is the function of, or in term of the non-dimensional variable, these things you can write the Z star and the T star defined previously. Okay, no problem. So because of the Z star, you can also write Z star and only, and this is the time, here is the time thing is there, so that's why we write the time. And here fr, that is the, this is already you know the fruits number. It is usually to compute the result of the dimensional analysis equation 20 to the exact analytical result, that is the equation 7. Equation 10, the method of repeating variable probably predict the functional relationship between the dimensional group. However, the method of repeating variable cannot predict the exact mathematical form of the equation. You already know this is the method of repeating variable cannot exact represent the your form, mathematical form of equation. So this is the fundamental limitations of the dimensional analysis. You know already the limitations, you have already know. The limitations is what? The dimensional analysis cannot predict the exact mathematical forms of equation. And the method of repeating, okay, analysis, the fundamental limitation of the dimension analysis, and the method of repeating variable. For some simple problem, however, the form of the equation can be predicted with an unknown constant as illustrated in the example whatever is written. So these are the some non-dimensional numbers. Some common established non-dimensional parameters or pi's. Why pi's? Because you have already seen pi is what? Non-dimensional parameters. That's why we can say the non-dimensional parameters also be known as the pi's. So in the fluid mechanics on heat transfer, you can take the screenshot of this. We have already time is so you can take the screenshot of this. So Pradeep, you have taken the screenshot of this.
Yes, sir.
Okay, so it is wish to choose the repeating parameters is what? The length and time and mass, as well as you can take the density, no problem. So just to, I have some slide also for to all of you. Just to take the screenshot. Okay, now this is also, you can take the screenshot. And one thing, no, I was some your fruit number is a square root of this inertia force divided by your gravitational force. You already know. That is the square. You already, when you derive the equation, the fruit square is equal to the inertia force divided by gravitational force. Here I think it is not written. But you remember. You can take the screenshot. Now it is very important kind of thing. Lots of researchers name is there. What one, the Prandtl, you know this name very famous in the fluid mechanics. The German engineer and developed the boundary layer theory, who is considered the founder of modern fluid mechanics. Before the Prandtl, the fluid mechanics was thinking another way, but after the Prandtl, very simply, very big problem we can solve using the boundary layer concepts. When you go deeper and deeper in the fluid mechanics, definitely you will. One example I have, you take the screenshot, the friction in the pipe. You take a screenshot of this, you take the screenshot. This is the final. Okay, I think these are the things is not important. Only the question is there. You can see here the wind tunnel. This is a wind tunnel. We have put here the big prototype and flow the wind, and you can see here the how the boundary layer is formed, how the stream is formed. This is a CFD thing. So question is there, you know already the Mach number. What is Mach number, Reynolds number, Weber number, Fruits number? You already know. Both you already know. If in the case of the ship, we use the Reynolds number as well as the Fruits number. If such type of question is you have seen in a exam, you just for do the dimension analysis. If the dimension analysis you will do, what you will find, one of the option was the non-dimensional, so that option is correct. So I have already, the dynamic similarity is what? For the dynamic similarity, the dynamic similarity is your geometric similarity should be there, kinematic geometric similarity, and the force similarity of force involved in the dynamic similarity. You can take the screenshot. You know the already. Okay, I one thing I want to tell also. Oh, one question was very important. The fruit number is what you already know, the velocity by root gy. So I think this type of question you know already. For x, this question was very important. If the one model is there, the acceleration was this. So how much the acceleration of the your prototype? The acceleration was similar. The acceleration of model and acceleration of prototype will be the same. How? Acceleration you know already is the velocity by time. If prototype and acceleration of model, the velocity of prototype, time of the prototype divided by velocity of prototype divided by velocity of model divided by velocity of prototype, time of model. So when you will do, what you will get, uh, your ratio you will get LR divided by LR. So that is the ratio is 1. So that's why acceleration of prototype is equal to acceleration of model. You go through this type when you write the such this question on the Google, you will get the answer of this. Not similar answer, but you will get. So these are the question you can take. So it's done.
Yes, sir.
Okay, we'll meet in the next class. Next class, I think, was about the Navier stone. Let's see what was the next week. So we have learned today the Buckingham pi theorem, how we select the, how we know the how much pi required. What is pi? Pi is the nothing but the dimensional parameters, non-dimensional parameter, not dimensional. How we choose the repeating variable. In the fluid mechanics, generally we choose the repeating variable as a length and mass or density, time. So this is a very basic concept, as one I think day of the, yes, here it is written very clearly, mass, length, velocity or density we can choose. So okay, bye bye, we'll meet again the next class. Thank you all.
Good night,
Okay,
sir.
thank you. Okay, good night.
Thanks.
Okay, thank you.